I want to warn you about a very common mistake that students make. And I see it quite often with logs, but it really boils down to misunderstanding notation. All right, this is function notation, which looks a lot like multiplication, but it isn't. Right? If I say 2x, then this is multiplication. If I say f of x, then that's not multiplication. You're not multiplying the number f times the number x. You're taking the number x and you're plugging it into a function whose name is f, and f may be doing something really goofy to x. Who knows what it's doing, right? This is not multiplication. This is multiplication. Okay, so right here you have x being plugged into the tangent function, and the result of the tangent function is being plugged into the log function. This is not multiplication. Right? So when you're taking the derivative of this, right, here's what's wrong. I'm going to write out this is wrong. This is what I see many times. I'm almost hesitant to write it down because then people will see me do it and say, oh, that's the way to do it. No, this is wrong. This is what they say. Oh, it's a product. So you got the first function times the derivative of the second function. Derivative of the tangent is secant squared, plus the derivative of the first function times the second function, right? This is wrong. This is wrong. This is do not do this. Don't, please don't do that, right? It's not a product. To say that the derivative of ln is 1 over x is completely wrong. The derivative of the natural log of x is 1 over x. The derivative of ln by itself, what's the derivative of the name of the log function? Well, the name doesn't have a derivative. The function has a derivative, so you got to have that whole function there in order to take its derivative. Okay, so don't do that. This is the log of a function. To take the derivative of the log of a function, you do 1 over that function times the derivative of that function. So the derivative of log u is 1 over u, but then the chain rule says multiply by the derivative of u. Well, the derivative of tangent x is secant squared x. So you end up with secant squared x over tangent x. Okay, that's the way you're supposed to do this problem. But I just warn you, and I'm hoping that you guys won't do it. It looks like a product, just because our notation for function notation of products look the same, but it's not a product. It's log of the tangent of x, and hence there's a chain rule in there. Okay, not a product rule. It's not log times tangent x. It's log of tangent x, chain rule. There you go.